Hello, everyone, and welcome today. I'm excited to host today's DevSecOn Canada talk. Today, Samuel joins us as we explore how AI and Web3 are reshaping the industry, driving automations, decentralizations, and innovations. But with these advantages comes a lot of challenges like scalability and security. So today, we'll explore how DevOps practices integrate with DevSecOps pipelines to explore how industry can adopt AI, Web3, and cloud technologies securely. Now, to dive deeper into this, let's hear from Samuel. So, Samuel, over to you.
Yeah, hi. Believe everyone can hear me. I'm Samuel, and I think it's fair to give a little introduction. I'm an SRE engineer, and I've been building software solutions for say about 8 9 years. So I'll have to say almost a decade. Built from regular software engineering platforms, fintech, Web3, did a little stuff with AI, and
Amazing.
I've kind of had a chance to like merge all of these experiences, and try to share them every time I get a chance to. So yeah, just like Dolly said, first of all, thank you, Dolly, for giving me a chance. I'll be talking about DevOps at the crossroads, more like teaching us what it means to enable and build secure innovations for AI, Web3, and even any other regular field. Yeah. So yeah, pretty much that's. I think that's good for an introduction. If you don't mind, we could start share the slides and yeah. Okay. Yeah. Just like I said, DevOps at the crossroads, um, enabling secure innovation. From AI, Web3, and beyond. I've had a chance to build for health tech, at some point transport tech, and as much as you have to approach every field has its own peculiarities. As much as you have to approach each of those fields from different perspectives. There are certain things that are common shows, especially things that deal with security, deals with protection. I had a conversation not long ago on my podcast where I talked about building, secure pipelines and ensuring that developers don't exchange security for speed. So those are some of the things I would try to touch on a little bit today, and I hope that I can like rearrange your mindset a little bit on approaching some of these solutions. Don't worry whether you are an entry level, you're intermediate, or you are mid level, or you are senior. I guess you're just gonna pick something out of the conversation. So yeah, I can move to the next slide now. So like I said, we're truly at a crossroad in the DevOps world, and the practices that served us well for like traditional applications, I think they are being stretched to their limits. I think it's fair to say that. I kind of got in the industry and Web3 was just becoming a thing. Of course, Web3 has done, say, Ethereum. Ethereum white paper came out in, this is 2025, so about 10 years ago, when the white paper was first released. So I guess, or when it started building, I think the white paper came a little bit before then. You know, I've seen that whatever practices we've used in the traditional application world has been stretched to its limit. So we're kind of tackling very emergent systems, blockchain technologies, AI models with different behaviors that can sometimes surprise even we, who kind of work with the developers. So the essence of this talk is just to reawaken us to the mindset that there are certain things, certain mindsets that need to change while we're building. And that's the essence of this first slide. Let me start with what I call the innovation paradox. I personally believe that DevOps isn't just about the pipelines anymore. You know, today we're like redefining its role in like I think I should put it this way: securing the bleeding edge of innovation. Take for example, I have two symbols here. Okay, one on one side we have security, which is like the lock representing protection, safety control. On the other side, I have innovation. Now, there has to be some sort of creative spark that drives progress and competitive advantage. And that's the essence of these two things. As much as we want security, I mentioned something about not exchanging security for speed or for innovation. You know, as much as we want to do all we want to do, we have to look at these two important extremes of building software tools. And maybe I should ask you a question I, that I bet keep some of you awake in the night. And that's why I put the poll question there. what concerns you more? Do you think you don't deliver innovation fast enough? Do you think you want to prevent catastrophic breaches, or both of them? Many times people want to pick one. I mean, I've worked in several startups, and we're always about speed, deliver, somehow push the innovation, get the founders happy, get the investors happy. Those things are nice, but I think a mix of both is what makes a good company. And personally, that is precisely what I call the paradox. We must realize that the future belongs to teams that can reconcile both the security and the innovation seemingly. I mean, the opposite forces. And we must realize that the future belongs to those teams who can put them together, quietly. Maybe we should unpack, we should go into more details, basically. So, I think to understand where we are going, we have to look at how we got here. There is a saying I used to hear when I was very young. If you don't know, a person who doesn't know where he's coming from can never tell where he's going, because he can't exactly tell his current position. You know, so I feel like we could put the same analogy in what we're discussing tonight. To understand where we're going, let's look at how we got here. If we look at this timeline, we have stage one, which is like traditional DevOps. The focus was simple: get code to production fast. I kind of got into the industry at that time. It wasn't really fading out as it is now. So I have a personal feel on how it used to be to move code to production fast. One thing I would let you know tonight is, I'm sorry I'm saying tonight. I mean, I'm on another part of the world. Anyways, one thing I want you to understand is I'm going to try to piece out some of my ideas from personal experiences, not just, documentations and stuff. So, yeah, in stage one, at the time of traditional DevOps, when we just moved from the days of manual labor in deploying cloud applications, as soon as the advent of DevOps, came into play, the focus was simple: get code to production fast. Whatever it is, set up the pipeline, set up everything. We broke down the wall between development and operations. At some point, if you understand the history very well, at some point it was first developers, then sysadmins, system administrators, and then DevOps came in. So the DevOps guy was like, okay, let's be the sysadmin guys were not able to like deliver fast code because they didn't exactly understand how code, operated. They just were experts in building the platforms. So the DevOps guy more like, okay, I'm gonna come in the middle. I will have every information from the sysadmin side and every information from the development side. And that's the essence of DevOps. So we kind of, in the stage one, we kind of broke down the wall between development and operations to more like accelerate delivery. In stage two, we saw the rise of, you know, development, security and operations, more like recognizing security. Um, I think it was at this time, I can't exactly pick out the years, but I think it was at this time that security was not was no longer an afterthought, but every team began to think of how to integrate it in the pipelines, and make sure everything you're building is secure all along the way. And then stage three. Stage three is kind of where we are. I think I dare say that's kind of where we are. That's kind of where many companies are today. When I say many companies, I think 60 to 70% is a safe number. We're asking, how exactly do we handle completely new technologies like AI and Web3? I worked in Fireflies. I don't know if you know Fireflies a lot. I worked in Fireflies AI for a little bit. I've spent almost half a decade on Web3. And I've come to realize that the problems are entirely new. They're not new as per we can't solve them, but it's not the regular, you can't guess your way through the process like you might try to do in the traditional DevOps setup. So the question is, how do we handle completely new technologies like AI and Web3? For the regular microservice infrastructure, I think it's pretty much a little easy, but the question mark on this very part is deliberate because we're still trying to figure out the right approaches. There are not enough documentations. There are not enough API details. there's a lot of knowledge gap when it comes to figuring out how to build infrastructure for these pipelines. I mean, it would be nice to have people write books, write documentations, write different stuff, but I think it's safe to say we're still figuring out the best approach in building very stable infrastructure for AI and Web3. Stage four, I guess stage four is where we've not reached, but I think stage four for me represents where we need to be. More like a unified approach where security, innovation, operational excellence, UX design, platform engineering, everything beautiful about building a very stable infrastructure comes into play, whether you're in AI or you're in Web3. I mean, you might say, why am I focusing on AI and Web3? I think those are like the biggest talks in the industry today. So, yeah. So the key message here is, just like I wrote there, we are not just adding security checkpoints. We want to build a completely new way for development and operations to enable innovations that are very secure by design. So security is not an afterthought, it's discussed from the word go. And we're kind of approaching the problems based on the use case of the industry. Yeah. So I'll move to the next slide. Now, I guess the next question is, why does this matter? Why does this matter now? For both the people who are new in the industry and those who are already experts, I think I need to make a very concrete real scenario. And I try to get this, I got from the internet, of course. If we remember very well, just a while ago, we had a breach just by manipulating an AI training model, and changing the model itself. I mean, there've been other breaches even in Web3. I was reading on some of them just in the previous week, and I realized that some of the biggest ecosystems are not even ready to work with some of the companies that have been breached. So sooner or later, it's a problem for everybody, both for the engineers and the builders. But I think the diagram I put here shows a typical setup of how the attack point was or how the attack point can be in AI models or Web3 protocols or data pipelines and even regular APIs. I think we must realize that attackers don't need to break the core technology. They just need to find the weakest connection point. And I guess that's the essence of why we have bounty hunters, right? I have a friend who suggested that many companies should encourage giving some sort of reward to bug bounters, or bug bounty hunters. I think that's the right phrase to put it. That's how to put it. Because those guys kind of take their time to find the weakest point in our building. But many times it's easy to have so much weak points if we don't have certain conversations at the beginning of the process, at the beginning of your building, at the beginning of your infrastructure conversation. I know in startups we just want to write code, we just want to ship, but maybe we should take some time and do an ADR. Maybe we should have an extensive conversation. Understand the place of security in every part of whatever solution you're trying to put together. Now, I should also share some statistics. Just like it's written on the slide, 3 out of 4 AI and Web3 projects face delays because of security concerns. Yeah, I paused a little bit so you can think about that. I mean, I feel like that's not really good. A single security mistake in Web3 can cost billions of dollars. I mean, we're talking about transactions in big ecosystems, say Ethereum or Polkadot or whatever. It could cost billions and billions of dollars. I mean, you can take some time and read about different hacks or different introductions. It's not been funny, And most AI security problems happen at the connection point between the systems, not really the AI model itself. So which means there are lots of conversations that need to be had before the systems are even built together. So the very technology itself is not in contention, but how the system interacts together. And that's why I always encourage that as much as possible, distributed systems knowledge should be something we shouldn't take for a joke, whether you're an entry level, you're a middle engineer, or you're an expert. I think distributed system knowledge is required for everybody. So that's another thing. Now, I think I'll end this slide by saying traditional security is like guiding a building with fixed walls. I want to make this as plain and as physical as possible. Traditional security is like guiding a building with fixed walls. Today's challenge is securing a building where the walls keep moving and changing shape. Now imagine you're in a maze and somebody's on top just changing and changing and changing. I think that's how it is. I think that's my best description of the current, state of things right now. And that's what makes this so difficult, and important. So, um, what is different about these technologies? I've been talking so much about Web3, AI, and all that. What exactly is different about it? I think to tackle these challenges effectively, we need to understand what makes AI and Web3 applications fundamentally different from the traditional ones. Traditional apps have very fixed behaviors, or I could say predictable behaviors. So if you write, if condition do this, else do that, you always get the same result. Just like I've written, any regular software engineer should get this. The code is very transparent, it's predictable. I can almost tell the behavior closing my eyes. But in contrast, AI and Web3 apps exhibit emergent behaviors. And I'm not saying this from a doc's point of view, I'm saying this from an experience point of view. AI systems, take for example, you have ever-changing data. AI systems learn from data and their responses can evolve in ways that even the original programmers didn't explicitly, code the programs. So the behavior emerges from the data rather than being explicitly programmed. And I think that makes it not predictable and makes it a little bit difficult. Traditional applications are just like, clay. You can, maybe find a way to melt the clay and remix it, do whatever, fix any mistake anytime. You push an update and the problem is solved out of the box. But Web3 applications are like concrete. I think concrete is the fair word. Once you deploy on a blockchain, once you deploy whatever on a blockchain, many things are immutable. You cannot exactly change them. I mean, you're talking about syncing. You're talking about number of epochs. You're talking about CEs. There are lots of technologies that comes with building a very secure, service or secure platform for Web3 applications. So these fundamental differences that we're talking about requires us to like rethink, kind of come up with better solutions on how to build, test, and secure our systems. And that's why I always encourage for the traditional applications, maybe you don't have to have lots of lengthy conversations. But I think for AI or the applications, there must be conversations to understand the nitty-gritties of the platforms we're dealing with and be able to rethink our approach to building and testing every part of the infrastructure. And I think this is where I come up with some sort of a new DevOps approach. And I don't know if I'm an authority on these, but I think I've spent some time to be able to say how certain things should go. So what does this new approach look like? I would propose a 4-stage process. It more like revolves around what we already know, about DevOps and emergent technologies. But first, we need testing for surprises. Now, there's something we call chaos engineering, and this is where it's kind of going to play into. This means testing for surprises just means teaching our systems to expect the unexpected. Now, that's crazy. It sounds like you're trying to predict the future. But there is what we call role playing and what we call scenario based setups. And those are the kind of things that are more like coming to setting up testing, setting up the application for surprises. So say you teach the system to expect the unexpected, it goes beyond the traditional test case to explore how systems might behave under unusual circumstances. And that's why I said chaos engineering, the knowledge in chaos engineering and distributed systems will come in very handy here. Secondly, we need to have bulletproof connections. Bulletproof connection in clear language, it just means focusing on securing the bridges between the technologies. Remember, I said we need to realize that sometimes the technologies itself don't have a problem, but there needs to be a merge. If I'm going to have a service within the cluster, talk to another service in another cluster, or talk to something beyond the network, there must be some sort of way that keeps me secured. It must be in such a way that if I have RPC connections, I have rate limiting protections, the bridges, whatever bridges comes in between. I'll give you a typical example. In a very traditional way, even in a very traditional architecture, you have microservice. Say Netflix. I think one of the biggest way Netflix builds their infrastructure is microservices. They use microservices. So whatever whatever they build as a service itself, whatever they build as a service itself stands out. And it's almost difficult not to deal with that. But whatever is going to connect two services together, then you got to be careful because you're dealing with services, you're dealing with IPs, you're dealing with load balancers, you're dealing with a lot of things. So whatever connection, that's where bulletproof connection, comes into play. This is where vulnerabilities are likely to occur. Third is always be on guard. Always on guard just means have better approach to protecting the systems. Or will I say, no, not protecting, viewing the systems. So as an SRE engineer, I'm always advocating for real-time viewing. I want to know what is happening every single minute on my system. Of course, we've moved beyond just regular monitoring and moved into actionable alerts. Actionable alert means I don't want to see anything that is not giving me a sign of trouble. And I want to arrange the alert in uh, decreasing order of importance. So I want red alert, I want severity red, I want severity yellow, I want severity maybe green, whatever it is. I want certain alerts. I want to be aware of every single move that doesn't seem okay to me, in my system. So yeah, so that's the essence of always on guard. And then the last one is self-healing capabilities. Now, I don't know much. I don't know how much you know about containerization. I'm going to use containerization as an example. Back in the day, when we used to use Docker Swarm, you know, Docker Swarm used to be very difficult to build a very self-healing infrastructure. Yeah,
Yeah.
it was really a pain, you know. And somehow Kubernetes came into the mix.
Mhm,
Now we must realize that Kubernetes was built as a platform tool for Google to use internally.
mhm.
Somehow it came out that, oh, this could be something that could be used globally, and everyone is using it now, and it's beautiful. Now, one of the things that made Kubernetes sell at the time was that it had the ability to like restart systems, see that systems could repair itself. That was the initial selling point. At least for me, when I got introduced to it, it was like, okay, I don't have to manage certain things myself. Kubernetes could come in to handle some of the self-healing processes. So yeah, I gave that example for you to understand where we're coming from and where we are supposed to be going. So I've had a chance to contribute features to Kubernetes myself, and I've realized how important it is to like see that your systems can self-heal. Of course, there is a bias that Kubernetes comes with more trouble than its advantages, yes, but I'm still a big fan, however. Yeah, so self-healing capabilities, when something does go wrong, the system should be able to automatically mitigate its damage. Of course, on call is very important. You could set up on pager duty, have different people watch out at different times, and then certain things can be jumped upon at certain points. So yeah, I think the everyday analogy I'm going to put here is that think of what I'm saying like a smart home security system that just not only detects the break-ins, but like predicts and prevents them before they even happen. It's rather proactive rather than reactive. I had an idea somebody shared with me, and maybe I should share it on this platform, that if we could have a product that has the ability to consistently project, no, I don't think project is the right word, predict the kind of problems, security problems, and vulnerabilities that can come up in our systems, I think that would be good. Not just something we could put in our CIs, but a platform of its own. I know there are some ideas out there, but a platform of its own that is enterprise grade, standard, and people could use it to like teams and engineering, setups could use it to like tell what could happen in their systems and more like advice. So um, I think it's time we talk about the real world challenges. I've said a lot of nice things, the importance of all of the things I'm saying, but I want to talk about the real world challenge. Let me share more like a real story. I think I call it the case of a mysterious model. A fintech company used by BlackRock deployed an AI model on Monday that worked perfectly in testing. By Thursday, it was making bizarre predictions. What happened? Market data has shifted just enough to confuse the model. But the solution wasn't more AI expertise. It was more about better DevOps monitoring. And I think this exemplifies the kinds of challenges we are all facing. AI that drifts when your AI slowly becomes less accurate over time, like a GPS, that's off by a block on Monday and a mile by Friday. Now, I don't know how much some of you have worked with the ChatGPT itself. When ChatGPT started, at some point it was pretty not good with its responses, not accurate with the responses, because the data that was being used to train the models were not exactly accurate, or not accurate is not the right word. I think they were a bit outdated. So certain things that were happening newly were not being talked about. So in a setup where you have an AI that drifts, then yeah, that's one problem. Secondly, you have blockchain uncertainty. When you can't be 100% sure of a transaction, like maybe sending an email that might arrive or might not arrive for 10 minutes. I mean, if I send an email, if in our email world today, I cannot close my eye and send an email and know that you're going to get it right on time, even if you're not online to check it, then that's going to be a problem, because communications, is going to be tied down. So the next thing is the security skills gap. Finding people who understand both worlds is as rare as finding a chef who's also a nuclear physicist. Um, okay. Okay, I think I jumped something. No, regulation confusion. I think I should mention that. Rules that haven't caught up to technology, like trying to apply a horse and a buggy traffic laws to self-driving cars. I want you to follow my thought process, because there are certain things I'm going to explain much later, and these things are going to come in handy. And then the last thing is the security skills gap. I think from experience, I can also say finding people who understand both worlds is very rare. And that's why I put the analogy. I mean, what is the possibility of finding a chef who is a nuclear physicist? That is how hard it is. And I think this also interprets or gives an opportunity for everyone to know that there is so much to learn and there is so much to build. There are opportunities for us to contribute to the ecosystem. So, but I think the reassuring part is every organization is facing these challenges. You're not exactly behind if you're struggling with them too. We are all like figuring all of this together, So, um, the success story. Okay, I'm just gonna make this full screen. The success story. How I'm gonna try to share a concrete success story from the project that a finance chain project at Compound Labs. It's a DeFi protocol that manages over 3 billion in assets. Before their transformation, they relied on manual security testing. They maintained a separate security process. They used paper-based compliance. They had a slow deployment pipeline and took a reactive approach to security. Now, after implementing the new DevOps approach that we've discussed hypothetically, it more like switched to an automatic attack simulation process. They were able to build security directly in deployment, created templates with like embedded security policies, streamlined the approval process, and even moved to proactive threat prevention. Proactive threat prevention is what I talked about, chaos engineering, and all of those. And I think it's fair to say the results are impressive. Problems were being, reached out 90% faster, could prevent, a $50 million security disaster. And we spend less time on talking about compliances. I mean, compliance is one part of software engineering that is not really talked about. And I think this is a good result. So the key insight here is the med security part of the process, not just a separate checklist. And integrating this approach is what, in my opinion, made the difference. So this is not a regular thing to say, but talking about AI that secures AI, this is the problem I think from experience could come in a few years. This is 2025, so let's say give or take 3 years. I know 3 years in Web3 or even the software engineering industry is a stretch. 6 months things could change, but that's okay. Just pardon my looking ahead. It's just an hypothetical situation. But I think by 2028, attackers would have evolved very quickly. And it would not be in such a situation that humans would be able to respond consistently with on call. I mean, I've been an on call engineer for more than 6 years, where I get a call by 2 a.m., I get a call by 3 a.m. to respond to an issue. But I think having an AI driven security process becomes very essential. And that's why I said AI securing AI. Google's cloud security AI workbench and even Microsoft's Azure AI security tools are more like pioneering, they're pioneering this approach already. I have experiences with some of these cloud platforms, so I think I can say fair that their approach has certain key components that we've also talked about. Having anomaly detection systems, automated testing systems, threat containment systems, and even self-healing systems. And the idea here is just having security systems that evolve very quickly. As a threat build, could the security system be able to respond? Yeah. Now, I think the solution is very clear, and we just need better security systems to more like evolve as quickly as the threats evolve, because the threats are going to keep evolving. Trust me. It would always have loopholes as long as we're building systems built by humans. Um, Now, when it comes to Web3 specifically, I think we face very unique challenges. And like I said, I spent some time here drawing from some of Chainlink Labs security practices for their $1 billion Oracle network. I think Chainlink is one of the biggest, undoubtedly one of the biggest Web3 organizations out there. And they have some security practices, that are public. I think the fundamental difference is that traditional deployment can be updated if issues are found. But Web3 deployments are often immutable, and I think I mentioned this before. And the single fact that changes everything is how we approach security. That's it. 3 practices that have proven particularly effective. They're very clear: multiple approvals, code as law, cross-chain safety. Each of them just means for multiple approval. Now, I think decentralization is the very focal point of Web3. And that is the essence of having multiple approvals. If you have multiple people that have to verify changes before they go live, I think decentralization should not just be about the solution model itself, but it should be brought back into even our engineering practices. We need to have multiple people approve, and verify certain changes, before some of those ideas go live. And I think this provides an extra layer, of protection to whatever feature has to be, shipped outside or shipped to production rather. Code as law is like writing rules that automatically enforce themselves and eliminate human error. I think some of these would have to be in some sort of CI process. We might not be able to say, oh, we have a code of law, and when we want to deploy something, we go bring out at least, oh, does this check, does this check, does that check? That'll be a very slow process. I mean, I'm a DevOps engineer, so we're all about speed. So we would have to find a way to build that into the CI, somehow get it into the deployment process. And then cross-chain safety is just making sure your systems work securely across the different blockchains. Interoperability right now is a big deal in the Web3 ecosystem. Every idea wants to ensure that every leader of an idea wants to ensure that they can relate with other chains at different levels. So remember this: in Web3, your deployment pipeline is as critical as your application code. The way you deploy matters just as much as what you deploy. So, but here's a game changer, that I think is inspired by Capital One's security automation process for their financial AI models. I mean, Capital One is a pretty big industry, so you could check them out. I think they're transforming static policy document into active code. And that's why you see that I have policy document and I have policy as code. On the left, we see the regular traditional approach: static documents, nobody reads, very separate from the implementation, manual compliance checking process. I think it's fair to say it's ineffective and burdensome. I've experienced it myself, so it's fair to say it's on that side of the conversation. But on the right is a transform approach. Security rules that are built directly into the code. You have like digital passes for like access control, you have automated compliance reporting, you have some sort of fingerprint approach embedded right in the code process. So if you notice, we're beginning to go into even developers. It's great that the DevOps guys and the SRE guys and the platform guys, infrastructure guys could build whatever they want to build, but developers need to have a way to have digital footprints, secure digital footprints for proper access control and automated compliance reporting right in the code itself. So I think the transformation is profound. Policies will move, policies stop from being paperwork and start being protection that helps rather than hinders. They become enablers of innovation rather than obstacles. So that's the essence of this slide. There is an obvious transformation in the ecosystem that we can take an advantage of and make our systems much more stable. Now, it's not just technology, but I think it's about the people. And pardon me for some of my topics. I want each slide topic to more like drive how it goes up in my head. I think based on Netflix DevSecOps transformation, for their streaming platform, they have one of the biggest microservice architecture in the world, and it's one infrastructure that I've always envied because I imagine how it's built to manage such infrastructure. I think Netflix and Monzo Bank in the UK, I think those are two companies that have fantastic microservice architecture, and I think they can advise on how DevSecOps is very important because, when you're dealing with microservices, you have to deal with how you're going to protect the communication between the systems. So I had to take my time to check out how Netflix is transforming development, security, and operations for their streaming platforms, and I think we can see that the organizational structure is just as important as technical tools. In the traditional model, development, operations, and security work is in silos. It hands off work to each other sequentially: build, deploy, audit. But in the transformed model, which is what is on the right, this functions more like work together in a continuous, secure delivery process. Again, emphasis on distributed systems. And they have like shared responsibilities and like integrated workflows. And this is what decentralization, security in decentralization, it's all about. So 4 key steps. I don't know, missing out. Oh, sorry. Yeah, 4 key steps that I think it's important in making this transition is: first, you got to embed security champions in every team. 2, you have to make security planning part of design discussions from the start. I think I mentioned this earlier on. 3, you have to update skill requirements for every role to ensure that you have engineers who have the basic security awareness. They don't have to be, in quotes, the greatest security engineers. They just have to have the consciousness of security when building solutions. And then you need to create incentives that reward secure innovations. Remember, I talked about rewarding people who are able to find out bugs in your systems, maybe from open source or even from internal engineers. I think we have to, more like recap on some of the key points. 1, new technologies require new security approaches. We must realize that what worked for the traditional applications won't be sufficient for AI and Web3. 2, integration points are your biggest vulnerability and opportunity. I can't reiterate the importance of this. The connection between your systems are where your most problems occur. It's beautiful to have integrations, but it's also a very serious problem. So you must be aware of the connection between systems. 3, security must be automated, not just added. And I want to reiterate on this because we're talking about moving fast and moving securely. Manual processes can't keep up with the speed and complexity of the modern threats today. Like I said, I've spent almost a decade in the industry. I think I've spent enough time to more like advise a little bit that the threats evolve over time. And To keep up with that speed, we have to automate whatever security process that we put in play. Let's see how this plays out in a realistic scenario. Imagine this: you are responsible for an AI system that suddenly acted strangely. What would you do? You have three options. First of all, the I know that the regular intuition from any engineer is to like roll back. Imagine if it's especially if it's a production system, you want to roll back to the last known good version. Git to roll back, blah blah blah. That's beautiful. That's nice. And it's a service option, truth be told, and I'm not going to run away from it. But I think it disrupts the service and doesn't solve the root cause. And I think it's a safe move. It's a very safe move, but it doesn't exactly does the job. I think the next option we have is you try to isolate the problem area while keeping the service up. So I think this idea balances continuity with safety, but it requires rapid problem identification. And I think I should also add here that you can only have an opportunity to do this if you have a distributed system that is well demarcated, where you can isolate a problem. If you have a monolithic application, whew, you are in for a ride. Trust me, I've had my fair share of that. You're in for a ride. So, but that's one option. Isolate the problem area while keeping the service up. This balances continuity with safety. And I think it also requires rapid problem identification for you to be able to isolate that problem. Another option on the table is you deploy a defensive system to like counter the threats. This is the most proactive approach, but it assumes that you correctly understand the threat. But many times, I don't know, maybe 70% of the time you don't understand the threat at first glance. You need to take some time. Sometimes you need to have suffered it to be able to go back, write some, what's it called now? I mean, this document, I can't remember the name now, but post-mortem document or something, post document that has been prepared after a security issue or whatever issue has been fixed. No, post-mortem. I apologize for saying post-mortem. Rather, I have a baby at home, so that's why that's over my head. Anyways, the key point here is that there is no single right answer. Yeah, that's a notion I want to drive. There is no single right answer. The context matters rather than the solution. That's why your DevOps approach needs flexibility built in. Different scenarios may call for different responses. Next slide. This is again up in my head. How do you know you are succeeding? I tried to do some research on DevOps research and assessment, DORA. If you don't know about DORA, it might be nice to take some time and read about their metrics. So I try to check what is adapted for the AI and Web3 environment. And there are certain key indicators that I use to track progress. Security verification speed. What this means is how quickly can you verify security? The goal here is to make this process as fast as possible without compromising the thoroughness required for the system. The second indicator here is the security innovation balance. Are you maintaining the right balance between security and innovation? Too far in either direction, it creates problems. The next indicator here is automated compliance. How much of your compliance process is automated? Manual compliance processes can't scale with modern development speeds. So whatever happens, we have to find a way to automate every of our process, from security to compliance to deployment, whatever it is. It has to be as automated as possible. There's a vulnerability correlation index here. This is just saying how well do we want to spot connections between the seemingly unrelated vulnerabilities. I think for me, this indicates the sophistication of your security thinking. How sophisticated are you thinking about the security approaches in whatever you're building, whether in Web3 or in AI? And remember, you can't exactly improve what you don't measure. So these simple numbers tell you if you're on the right track. Now, there's what we call KPIs. I don't think it's just about software engineering. I think it's everywhere. Key performance indicators. When deciding your KPIs, either as a DevOps engineer or as a thought leader in whatever tool or software you're building, it might be important. No, it is important to bring in the DORA metrics into your KPI discussion. Yeah. So that is how to know if you are succeeding. This is, I guess, for whatever happens, for everything we've talked about, there has to be a starting point. There is a popular saying that Rome was not built in a day. A journey of 1,000 miles start with a step. Yeah, popular saying. I'm just going to try to reference that. We have to try to start with the nitty gritties. Um, I heard I heard a wise man once say that he can't teach the people algebra if they don't know their ABCs. So whatever happens, we have to get started with, we just got to get started, and you don't need to do everything at once. I think this is a practical roadmap. Don't get overwhelmed with every big jargon that I have said. I try to make it as simple as possible, but if it sounds like a jargon to you, I apologize. But you don't need to do everything at once. Within 24 hours, you can run a 30-minute thread brainstorm with your team. Just getting people to think about the potential vulnerabilities is a very powerful first step. Just sit down, talk about your systems, especially people who build the systems. You can say, okay, I wrote this code. I think this part of the code is a problem. You know, that can be done in a day. Within the first year, you could implement strong identity verification. You could implement threat planning. You could implement very basic security checks. You could even, start using SonarQube and all of those fundamentals even in your CI. So I think within the first year, you can, for any regular infrastructure to be built, these fundamentals will like address the most common vulnerabilities. And then if we move a little bit further in the first 5 years horizon, you can work toward having like automated security testing, having zero trust principles, smart monitoring systems. These are like advanced capabilities, and if you have the team to do it, then go right ahead. um, it's fair to say the most important thing is to start with a 24-hour action. Don't let I think I heard someone say, don't let the perfect be the enemy of the good. It's nice to be in the future vision, but I think you need to start with the first step. And I should talk about your starter kit. To help you get started, I try to check a starter kit that is based on CISA and OpenSSF recommendations. Download Try to download your AI security template from very reputable sources, by the way. Join supportive community groups, groups that have like practitioners that are able to like share experiences. Try some beginner friendly tools that can grow your expertise. Follow a very clear skill learning path. Don't go all the way to the top. I think I'll use programming to explain this. It's nice to understand how to write clean code and have MVVM policies and all of that, but you need to know how to even write a function. You need to know how function interacts with themselves in a block of code. So follow a very clear skill learning path. Try to follow a learning path that will help build your team capabilities. You don't need to be an expert to get started. You just need to begin with the basics and grow from there. Um, One last insight that I want to share before I close is sometimes your greatest allies comes from unexpected places. And the CTO of Uniswap, he was the one who said, our compliance team now leads our most innovative projects. And I think where this comes in is the Uniswap story is very instructive. You could take some time and go read about Uniswap. Their compliance team, traditionally seen as a blocker, transformed into um, innovation enablers for their decentralized exchange. So it used to be that the traditional view sees compliance as a stop sign, but we have to find a way that, how will I say, the traditional view sees compliance as a stop sign, and this more like prevent progress for the sake of safety. But I think the transform view sees compliance as a guardrail, and this more like enables faster, and safer progress. And The people you might think would slow you down could become your greatest allies just with the right approach. So look for partners across your organizations or even across the ecosystems, and not just in technical teams. Yeah, this is a closing, and I'm sorry I've said so much, but I think as we conclude, I would leave you with what I call the pledge. In Nigeria, where I live, we have something we pledge, and we say I pledge to my country, blah blah blah. I think it's good to say I will not choose between speed and safety. I will architect systems that demand both. Um, I think the next security challenge won't wait. The question is, will your DevOps be ready? So, yeah, thank you for your attention today. If you'd like to continue the conversation, you can scan the QR. You have access to my GitHub, my email, my LinkedIn, Twitter, wherever it is. Just say hi to me, and I'll be happy to discuss these topics further. I hope I didn't bore you, but this is me, Samuel. Thank you for listening.
I like the pledge, Samuel. It was amazing. People like that. So, and I like the idea how you are exploring what the future of AI would look like, and probably will use AI to secure the things that we are doing today to bring up things, right? So, I like that concept, a fresh breath of air. People are enjoying it. I'm just going to wait if anybody has a closing session or any comment, but oh, people are pledging it with you. Brian, that's lovely. I'm just putting out the comments, Samuel, for you to view. So, Brian says that he really wants to connect and learn more. It's really good concept. Brian, we feel the same. That's lovely. Amazing, folks.
Yeah, you can just scan the QR code. It'll give you access to my contact card. My contact card has my email, my Twitter, LinkedIn, GitHub. Just give a shout out, and I'll be willing to have a conversation. Yeah, I
Perfect.
really hope you enjoyed the conversation.
Oh,
Yeah,
we did.
well,
We
I
did.
did myself.
You flooded with comments. We did. So, yeah, I hope everybody enjoyed the session today, and I hope it brought some valuable insight. So, folks, keep exploring, keep innovating, and let's make things better. Until we meet next time, I'll see you next time. Bye bye. Thank you. Bye.
Bye.